Okay, this is a video answer key for the practice sheet in preparation for our SWIC tomorrow. So hopefully people will have a chance to look at this and compare it to their answers and then come in with any questions they might have tomorrow. So the first question is, looking at this number here, we're supposed to say if each of these numbers here represents a factor, a multiple, both a factor and multiple, or neither a factor or multiple. So if I think about 6, factors of 6, well, 1 times 6 and 2 times 3. So really there's only 4 factors of 6, 1, 2, 3, and 6. If I think of multiples, 6, 12, 18, 24, and so on, as we skip count by 6. So I can see 18. Well, 18 is larger than 6, so there's no way it can be a factor, but it is a multiple because 3 times 6 is 18, so that's a multiple. 3 is a factor. 6 is actually both. It's on both lists. 26, no, I can't get to 26, so that's neither. 9 is neither. 1 is a factor, and 36 is a multiple. For 24, if I'm thinking about the factors, 1, 2, 3, 4, 6, 8, 12, and 24, these are all numbers that can divide into 24. And if I think of multiples, it would be 24, 48, and so on. So if I'm looking at this list here, 14 isn't on either list, 8 is a factor, 24 is on both lists, 12 is a factor, 6 is a factor, 48 is a multiple, and 3 is a factor. So that's how you'd complete that question. For question 2, it says, what is the greatest common factor between 40 and 54? And show all the factors. So I'm going to factor 40 first. I like factoring by starting with 1 and going through my divisibility rules. So 1 can be multiplied by 40. 2 can go into 40 because it ends with a 0, so 2 times 20. 3 can't, but 4 can, 4 times 10. 5 can, it's 5 times 8. 6 can't go in because 3 can't go in, so that's our divisibility rule. 7 doesn't go in, and then 8 is already here. So my factors are 1, 2, 4, 5, 8, 10, 20, 40. So I've listed all my factors, and there's 8 of them. For 54, 1 times 54. 2 can go in because it's an even number. It's 2 times 27. 3 can go in because 5 plus 4 is a multiple of 3. And if I were to divide 3 in here, so 3 goes into 5 one time, and then I'm left with 24, so that's 18. So 3 times 18. Or if you know that 3 can go in, and you use the multiplication chart, 3, I can keep going down here till I get to 54, and that's 18 as well. So that's another way I can use it. 4 cannot go in, 5 can't go in, 6 can go in, 6 times 9, and then 7 no and 8 no. So these are my factors of 54. So if I'm looking at all the factors here and I'm looking for common factors, I can see that 1 is common to both, and 2 is common to both. 4 is not on this list, 5 is not, 8 is not, 10 is not, 20 isn't, and neither is 40. So the only common factors are 1 and 2, which means the greatest common factor is 2, since it's larger than 1. On question 3, Kiara has 30 oatmeal cookies and 48 ginger cookies. So I'm kind of picturing like a pile of oatmeal here, and there are 30 of them. And I can divide that into a lot of different ways. I can divide them into sort of one group of 30, and I can divide them into 2 groups of 15, and I can divide them into 3 groups of 10. So you're kind of thinking of how you can break up this group of 30 cookies into equal groups. I can also do them 5 groups of 6, or conversely I can do 6 groups of 5 and 10 groups of 3, 15 groups of 2, and 30 groups of 1, I guess. So those are different ways I can divide up the oatmeal. For the ginger cookies, I have a big pile, there's 48 of them, and I can have one group of 48, or I can divide them in half, so 2 groups of 24. I can divide this into 3 groups as well. So 3 goes into 48, so I need to do either long division, so 3 goes into 4 once, and then I'm left with 18, so that's 16. Or I can use my divisibility chart. If I work down 3 until I get to 48, which is right here, that's 16, just to confirm. 4 can go into 48 as well, it goes in 12 times. 5 can't go, 6 times 8, so 6 can go and so on. So those are all my factors of 48. And I can have different groupings. For example, I can make 6 groups of 8, or I can make 8 groups of 6. So that's how I can sort of divide these up. Now, Kiara wants to make packages which contain both oatmeal and ginger cookies, and she has to evenly distribute the cookies so each bag has the same amount of oatmeal cookies and each bag has the same number of ginger cookies. So if this is a bag, for example, and I put 2 ginger cookies into it, or 2 oatmeal cookies, in that bag I would also have to put 2 oatmeal cookies in this bag and 2 oatmeal cookies in this bag, and so on. So I'm looking to see if there's any common factors between these two. And I can see that 1 is common, 2 is common, 3 is common, 6 is common, 10 isn't, 15 isn't, 30 isn't. So I have common factors of 1, 2, 3, and 6. So I'm going to say that she can make 1 package. And if she had 1 package, she'd have 30 oatmeal and she'd have 48 ginger cookies. But that would just be one huge package, kind of defeats the purpose. She could make 2 packages where she divides each of the types of cookies in half. So that would each would have 15 oatmeal and 24 ginger cookies. And I'm using my factors here, like 2, there'd be 15 of them. And if I divide this by 2, there'd be 24 gingers. I can do 3. So if there was 3 oatmeals, she'd have, 3 packages, she'd have 10 oatmeals. And if there were 3 packages, she'd have 16 ginger cookies in each. And if she had 6 packages, then she would have 5 oatmeals. And if she had 6 packages, she'd have 8 ginger cookies. So these are the different ways that she could do it. How many packages can she make? Well, she could make packages of 1, packages of 2, packages of 3, 1 package, 2 package, 3 package, or she could make 6 packages. And this is what would be in the packages depending on which one she chooses. On the other side of the page, question 4, this is kind of similar to our exit card. So we want to figure out which one of these numbers is prime, and then the ones that aren't prime, we need to tell why. So 1 is not prime, we know that right away, because a prime number has 2 factors, and a composite number has more than 2, but 1 only has 1 factor. The only factor of 1 is 1. So it only has 1 factor. So it's not prime. For 51, I'm noticing that according to my divisibility rules, 5 plus 1 is 6. So if I were to add up the digits equal a multiple of 3. And if the digits equal a multiple of 3, that means that this number is also divisible by 3. So this isn't prime either, which would mean this one is prime. On this one here, I can see that this one ends with a 2, so it's an even number, and even numbers mean divisibility by 2. So this would have factors of 1 and 372, but also it can divide by 2 as well, and I don't even care what it equals. I just know as soon as I find another factor, this one is no longer prime. 813, if I were to add up the digits, 8 plus 1 plus 3, that's 9 plus, so that adds up to 12. So the sum is 12. And since the sum is a multiple of 3, that means that this number is divisible by 3, as well as by 1 and by 813, so it's not prime. And so this one must be prime. For this last one here, this is sort of a extension problem because this is some stuff we're going to be doing next week, actually, with squares and roots and things like that. But we'll still see how we can solve this. So both the laundry room and the dining room are squares. So all the sides of the laundry room are the same, and then all the sides of the dining room are the same. In this case here, the area of the laundry room is 4. So this has an area of 4. And since length times width is our formula for rectangles, I need 2 numbers that are going to multiply together to get 4. So I could have 1 times 4 and I could have 2 times 2. But since it's a square, the sides have to be the same. So this is going to be 2 and that's going to be 2. Using the same logic for the dining room has an area of 25. So I need two numbers that multiply together to get 25, so 1 times 25, or 5 by 5. Since it's a square, it's going to be 5 by 5. The living room is a rectangular area, and it has an area of 30. And so for an area of 30, you could have 1 times 30, you could have 2 times 15, you could have 3 times 10, you could have 5 times 6. So these are all the different factor pairs for 30. And so I already know that the distance from here to here is 5 based on my dining room. And so this is going to be 5, which means this has to be 6. So far I know the distance all the way across here is 11, 6 plus 5. And I know the distance here, 5 plus 2, is 7. So now I have to figure out what are the dimensions of the kitchen. Well, I know from here to here is 2, because it's the same as the laundry room. But I need from here to here. So if I know that this entire distance all the way across is 11, but I'm subtracting this part. So the entire distance is 11, but I only need this distance. So I'm going to subtract this, which is 2, so this is 9. So the area of the kitchen is going to be 9 times 2, so that's 18 meters squared. And because this is a word problem, we're going to end with a therefore statement. The area of the kitchen is 18 meters squared.